Hey there, what's up? We're learning some gas law stuff in nurse anesthetist school, and it's all pretty basic stuff you probably learned in high school. But just to go over some of the things that we're going over in school, I'll show you a little bit about the gas laws and show everybody an easy way to remember all three of the major gas laws with one easy to read diagram. So here's a whiteboard here. I'm going to draw a triangle, like so. What we're going to do is on this bottom right hand side, we're going to put C for Charles. This side, G for Gay-loussac. And the top, we're going to put B for Boyle. We have Charles' law, Gay-lussac's law, and Boyle's law. Here we're going to put a T for temperature, P for pressure, and V for volume. Okay, so the mnemonic for this is you can do dirty ones, you can do clean ones, whatever you want to do. But the one the teacher taught us was, could those guys possibly be violinists? Of course, you know, the students made up their own, and I think the one that I like the best is, could those girls possibly be virgins? So anyway, you can make up your own mnemonic for that, but in any case, we'll start with this bottom one and go over Charles' law over here. Charles says that volume over temperature, V1 over T1 equals V2 over T2. So if you increase the temperature, you're going to increase the volume of the gas. Okay. Over here on the other side, P, your pressure's constant. So the two closest ones to Charles is volume over temperature. Okay. Next one we'll go to is Gay-lussac, G over here. Two closest ones to him are pressure and temperature, with his constant being volume over here. Okay. Gay-lussac, P1 over T1 equals P2 over T2. Gay-lussac said if the temperature increases, so will the pressure. Okay. You can see that by putting a balloon, two balloons, one in hot water and the other one in cold water, and one in the hot water, the balloon will expand. If you put it in cold water, icy water, the balloon will get a little bit smaller. Okay. Last one we'll talk about is Boyle. This is kind of a big one. Deals with pressure and volume, with temperature being the constant. But his is a little different. His aren't on top of each other like these ones over here. They're right next to each other. So P1 times V1 equals P2 times V2. Okay? Now with this law, it says that pressure and volume are related to each other, but not like these ones over here. See, if you increase this side over here, like let's say this pressure is 3 and you make this pressure like 4, your volume is going to go down. So they're kind of opposite of what the volume over temperature and pressure over temperature are. So it's kind of an inverse property. But you can figure this out algebraically and it all works out. P1 over V1, or P1 next to V1 here. Let's do this here. P1 times V1 equals P2 times V2. Say we have the pressure of a gas is, let's just say 50, make this easy. And the volume is 2 liters, okay? 50 milligrams of mercury, milliliters of mercury. Millimeters of mercury, I'm sorry. And let's make the pressure over here, or let's make the volume greater here. We'll do 4 liters. So we want to find the pressure over here. We're going to do P1 times V1, which is 50 times 2. It's going to be 100, of course. And over here equals 4 liters times X. Of course, we're going to divide 100 by 4. We're going to get 25 equals X. So our X value over here, or our pressure, is 25. So we increased the volume over here to 4 liters. Pressure went down. It has an inverse ratio. So you increase the volume, pressure goes down. And the opposite would happen if you increase the pressure. So that's how those work out. But anyway, that's what we're learning with gas laws. And hope you found it interesting. I thought it was kind of interesting. But I found that triangle to be somewhat helpful. And just kind of helps you remember to keep things in order. And whoever thought of that triangle is a genius. So, in any case, that was it. Hope you weren't too bored. Have a good night. Bye.